All right, let's do the exciting last question here. 2.12 seconds, let's figure it out. Okay, so here's the building. All right, here's the ground. Here is, windows. You gotta have windows in your building, right? Here's Freda standing dangerously on the side of the roof, right? She throws the ball up, and from the first part of this one, and I solved this in the first video, we know that she's actually throwing this ball upward with a velocity of 12.8 meters per second, okay? Now, unrounded, it's 12.800, okay? So she throws that thing up, it goes up, right? It goes down, okay? And the question here is at 2.12 seconds after the ball is released, what's its velocity and what's its displacement? Now, just looking at this, right, it's actually going to go up for about, well, 12.8 divided by 9.8. It's going to go up for a little more, like 1.3 seconds, right? Okay, so I fully expect the thing to be on its way down, a negative velocity. I don't think it will have passed this point yet. Okay, I think it will still be above her. Okay, now of course you can look down here; those are the answers. But let's just solve this, right? So let's set it up. Let's go from Freda to 2.12 seconds. We're going to suvat. Okay, displacement, we want to know what that is. The initial velocity is 12.8 meters per second. Acceleration is negative 9.81. Our time is, that's the 2.12. Right, and then of course we've got formulas that just come right out of the box that find these things for us. So let's find the velocity. Velocity is u plus at. Right, so velocity equals 12.8. And then it's actually 12.800, right? Plus negative 9.81 times 2.12. Now, presumably, yeah, if we put it in 3.78, we get this, but we're putting in that. So let's try this. Okay. Okay, plus negative 9.81 times 2.12. And I'm getting negative 7.997. Okay. 97 meters per second. I'm using an unrounded version of this. I've got like this stored in my calculator. So I've got that, and now with 3 sig figs, if we had 3 sig figs, right, we'd say negative 8.00. Okay, so there's our velocity, right? It's on its way down. We know by its velocity that it's actually above us, right? Because when it passes her, it'll be going negative 12, okay, meters, negative 12.8 meters per second, right? When it reaches that same elevation, because that's the speed she threw it up with. So we know it's actually up there. But let's just go ahead and solve that, right? Let's solve for the displacement. Okay, so I'm just going to use this guy. S is ut plus 1/2 at squared. Okay, and we just plug these numbers in, right? It's going to be 12.8 times 2.12 plus 1/2 negative 9.81 times 2.12 squared. Don't forget to square that. If you don't square it, it won't be squared. Okay, so here we go. Let's see. Get that. Okay, so 12.8 times 2.12 plus 0.5 times negative 9.81 times 2.12 squared. Have I typed exactly that in? Indeed I have. Okay, let's try this. 5.091. Positive 5.091 meters. So indeed it is still above where she is, right? That's not the distance above the ground. In fact, once it goes past her, these are actually negative displacements. These are positive displacements. So it is still above her, right? It's still above her. It's moving down. When it reaches her elevation, this velocity will become negative 12.8. When it strikes the ground, it will be negative 24.3. And there you go.